Hello everyone, I'm Mika, and in this video I'll try to explain pointers. Many people struggle with pointers, they just cannot seem to understand them. Even professional software engineers with decades of experience have confessed to me that they don't fully grasp pointers. That's always baffled me. As far back as I can remember in my software engineering journey, I never had trouble with pointers, and I think I know why. The second programming language after BASIC I learned was PDP-11 assembly. Then I was a kid, I had a Soviet computer, clone of the PDP-11, the BK0010. The inventors of C language first implemented the C compiler for the PDP-11, and I feel like the language maps closely to the concept of PDP-11 machine code and assembly. So I'm going to give it a shot and explain pointers the way I learned about them. In fact, I did not really learn about pointers in the traditional sense. The knowledge came to me intuitively from my understanding of PDP-11 assembly. As you know, computers have different types of memory: CPU register, CPU cache, hard drives, VRAM, RAM, and RAM, random access memory, is one of the most important components. Most of the time, the program manipulates bytes stored in RAM. RAM is just a bunch of cells that can store zeros and ones. They are called bits. Group of 8 bits form a byte. Each byte in RAM has its own address. This is how you tell to CPU to read from or write to that byte. An address is simply a number. To store a number, we need a certain number of bits. Modern CPU are 64-bit, which means each RAM address is represented by the 64-bit number. In computer science, we call this an integer. So on a modern 64-bit CPU, each byte in RAM has a 64-bit integer as its address. This is why it's called random access memory. We can give the CPU a random address, 64-bit integer, and it can quickly retrieve or store the byte at that address. And since an address is just a number, it can be stored in RAM as well. To store a 64-bit address in RAM, we need 64 divided by 8 bytes. Let's practice a bit by writing a small C++ program. Here we declared a variable I of type int and assigned it the value 69. What does it mean? The compiler will allocate some storage in memory for an int. Typically, an int takes 4 bytes. So the compiler will reserve 4 bytes in RAM. Let's say it's assigned this memory starting at address 420. That address could be anything, but we will use this concrete number to reason more easily. Let's run the program and see that output we get. Now let's extend the program. We declared another variable p, which is pointer to an int, and initialized it with null pointer. Null pointer simply means address 0. What does it mean? The compiler will allocate memory for a variable of type pointer to int. The pointer is just an address. As we discussed, an address on a 64-bit CPU takes 8 bytes, so the compiler will reserve 8 bytes in RAM for this variable. Usually, variables declared next to each other are stored close together in memory. So if I is at address 420, p might be at address 424. After running the program, we will see the following output. Let's extend the program further. We assign to p the address of I. The ampersand I means address of I. which is 420 in our example. So now instead of storing 0, p stores 420. The program outputs. Notice the pointer value is different. This is because the allocated address depends on many factors: how much RAM your PC has, how many programs are running, what types of programs, and how long your computer has been running. Your computer is constantly allocating and releasing bits of memory. Let's look at another example where we assign values, not pointers. We declared variable j of type int and assigned it the value of I. The compiler will reserve 4 bytes for j, most likely at address 432, and copy the value 69 from I into j. Output is. Hope this helped you understand pointers a little better. A bonus example: changing the value of variable via pointer. Output is. Try to understand what happened here on your own. If you're able to grok it, you truly understand pointers. Thank you for watching and see you next time. Bye!